Hello everyone, my name is Uzair Khan and I'm part of the math faculty at Mastermind. Today I will be solving this question that you can see on the screen. It's from the IGCSE math past papers 0580. It's from May-June session 2016, question 7 from that paper. So this question is from the topic trigonometry, further trigonometry to be exact. So what you can see on the screen is the question which says the diagram shows a design for a logo made from a sector and two triangles. So this is the sector. These are the two triangles. One triangle is being made by the radii of the sector, and the other triangle is right beneath it. Okay. So the sector with center O has a radius 8 centimeters and a sector angle of 210 degrees. The length AC is 8 centimeters and the angle ACB, which is over here, it's 72. Now the first part is saying show that the angle OAB is 15 degrees. Now OAB is basically this angle right here because it's coming from O, it's at A, it's going all the way to B. Now this angle, let me write down the short statement, let OAB, the angle OAB, equal to x. So basically I've assumed this angle as x degrees. Now the next thing that you see in this, there are two things in this that you need to remember. The first thing is that this triangle OAB is actually being made by the radii of the sector. So this right here is the radius of this sector as well as OB. So length OA and OB both happen to be the radii of this sector. Now what that means is that these two lengths are therefore equal, which makes triangle OAB as an isosceles triangle. So therefore this angle right here will also be angle X. It will be the same as angle OAB. Now the third thing is, in order to calculate a missing angle in a triangle, I need at least two known values. Now these two happen to be the same angle, which is fine. I need the third angle, which is this angle right here, angle AOB. So I don't have that yet, but it's very clear that I can calculate it very easily. So I'm going to do a small calculation on the side. So for AOB, what I'm going to do is I'm going to subtract 210 from 360. And that will give me angle AOB as 150. So I get 150 over here, which completes the triangle for me. And now I can calculate the missing angle, which is angle OAB, very easily. So I'm going to do angles in the triangle. X plus 150, the sum of angles in the triangle is 180. And there we have an algebraic equation. I'm going to shift 180 on the right, I'm going to shift 150 on the right. So that leaves me with 2x equals to 30. And I'm going to solve it over here. X is equals to 30 divided by 2. And that leaves me with x as 15. Now we had already taken OAB as x, and x turned out to be 15. Therefore, OAB is equal to 15 degrees. And we write a small statement of hence shown. And it's useful to write hence shown in show that questions. So this part is complete. Let's look at part B in this. Now it's asking for the length of the straight line AB. For that, we can go back to the question. And this length happened to be the baseline of the triangle, length AB. Now let's assume this to be y. Let AB equal to y. So I'm going to label y over here. Now, in order to calculate this, there is a concept in trigonometry, in further trigonometry, called the sine rule. The sine rule says that if you have a triangle ABC, which this is labeled as ABC, this is small a, this length is labeled as small a, this length is labeled as small b, and this length is labeled as small c. So they are labeled with small letters with respect to the angles they are opposite to. So if this length is opposite to angle A, this is labeled as small a. The length is labeled as small a. This is angle A, this is angle B, and this is angle C. Now the sine rule suggests that the length of A, the ratio of the length A and the sine of angle A is the same as the ratio of length B and sine of angle B, which is also equal to length C, the ratio of length C and sine of angle C. Now this is the rule that I'm going to use here to calculate the length of AB. And the way I'm going to use that is because, let's go back to the diagram. I happen to have this angle right here, and the length opposite to the angle 150 is what I need to calculate. So, and I happen to have this length over here, the radius, and the angle opposite to it is what I've found out in part A. So I'm going to use that. So I'm going to do, what I'm going to do is 8 upon sine of angle 15. 8 is the radius over here, and the sine of angle opposite to it is 15, which should be equal to this length right here, which I've labeled as y, which you can also take it as AB. It's completely up to you. We can completely cut this one out. And that happens to be opposite to the angle 150. So it will be upon sine of angle 150. Now, since this is paper 42 or the extended paper 2, you are allowed to use calculate this. So first I'm going to find out the values of sine 15 and sine 150. Sine 15 happens to be 0.259. So this is 8 upon 0.259. And sine 150 happens to be 0.5. So in order to find AB, I'm simply going to shift 0.5, which was being divided by the length AB, and shift it to the other side in order to multiply it. And using the calculator, you can easily find out the length of AB, which will turn out to be 15.44. And if because obviously it's the length, we need to check for the unit. And it happens to be centimeters. So the length of AB is 15.44 centimeters. Over here, the unit is already given, so you don't need to worry about putting it down. Now that part B is done, let's move to part C. Part C is asking for the angle ABC. Now let's go back to the diagram and see the angle ABC is actually right here, is what we need to find. Let's label it as angle Z. And there are a few things to notice. that the missing angle is over here. The length opposite to it is given to us. And we have one other angle over here, which is 72, the angle ACB. And the length opposite to it, we just found out, the length AB, we just found out in part B. So it's obvious that we can use the sine rule again. So, which will be, but this time we're finding out the missing angle. In the previous part, we used the sine rule to find out the missing length. So this will be 8 centimeters divided by sine of angle Z equals to, the length that we found out was 15.44, because let's go back to the term. The length happens to be AB, which is opposite to the angle that is known to us. That's why we're going to use that length, which is 15.44 upon sine of angle 72. Now, in order to carry on this calculation, I'm going to first find out the value of sine 72. That is 0.95. So 8 upon sine of angle Z equals 15.44 upon 0.95. Now I'm going to do, in order to solve this, the missing value is basically in the denominator. What I can do is flip the fractions in order to bring the missing value in the numerator. And yes, I'm allowed to do that because I have fractions on both the sides. Either I can just flip the fractions on both sides to make it equal. So what I'm going to do is sine Z comes on the top, 8 goes on the bottom, and same goes over here. 0.95 will come on the top in the numerator, and 15.44 will go in the denominator. And now I'm simply going to shift it and multiply it on the other side. So sine of angle Z is equal to 8 multiplied by 0.95 divided by 15.44. You can also always do this. First multiply it on the other side, the denominator, shift the denominators on the other side and multiply, and then further divide. You can always do that as well, but this is a shortcut method. It will save you some steps. So let's first find out what that fraction is equal to. It's going to be 8 times 0.95 divided by 15.44. So that gives me sine Z equals to 0.492. And in order to find the missing angle, I will have to shift the sign on the other side, and I can't divide it, but what I can do is sine inverse, which you can easily calculate using the calculator. Sine inverse of 0.492. That's giving me 29.47. Now we took angle ABC. We assumed angle ABC as Z. Therefore, angle ABC happens to be 29.47 degrees. So this part is also done. Now let's move on to the next part, which is asking for the area of the logo design. In order to find the area of the logo design, we will go back to the shape. What we see over here is, let me just clear this out. There are 3 regular shapes in this. So this is shape number 1, which is a triangle. This is shape number 2. This is shape number 1, which is a sector. This is shape number 2, which is a triangle. And this is shape number 3, which is also a triangle. Now in this case, in this shape in order to find the area of the whole shape, I need to find the area of these shapes individually. Shape number 1, the sector, the triangle number 2 and the triangle number 3. I need to find the areas of these shapes separately. Now, if we go back to the part, it looks like a lot of work for one part. So it's also good to check how much marks it's worth. So it's actually worth 6 marks, right? That means it's justified because it requires a lot of work. So let's find out the area of the first shape, which is area of the sector. Area of sector, let me also label it accordingly, number 1. Now, in order to calculate the area of the sector, you need the angle, which is theta upon 360 multiplied by pi r squared. When we go back to the diagram, we can see that the theta, the angle, is 210 of the sector, and the radius is 8. So we can find out our angle of our area of sector very easily. That's 210 upon 360 multiplied by pi value is 3.142. Since we can use the calculator, we can use the value 3.142 very easily. R squared is 8 squared. Let's use the calculator to find it out. So it's giving us 117.3 centimeters squared. So the area of the first shape is done. Let's go back to the shape for area of the second triangle, which is a triangle, yes. Now, in order for that, now this is not a right angle triangle, so I can't use the formula 1 upon 2 times the base times the height in order to find the area of this triangle. But in order to find the area of non-right angle triangles, what I can use is the sine rule for area, which happens to be 1 upon 2 times length A times length B, and I will show it to you over here. So if we have a triangle that's labeled A, B, and C. So I need the angle C for that. I need the length A, which is obviously going to be labeled opposite to the angle A, and angle B, length B will be labeled over here. So for the area of triangle, non-right angle triangle, it will be 1 upon 2 times length A times length B and times sine of angle C, which is why it's called the rule as the sine rule for area. And I'm going to use that exactly over here. So the length A will be this, 8. Length B also happens to be 8 because it's also the radius of this sector. And the angle C is going to be this one, which we did calculate earlier. And for the first part, is going to be 150 degrees. So we have our A, we have our B, we have our angle C as well. So we can easily find out the area of this triangle as well. So area of triangle B, triangle 2, sorry, area of triangle. I'm going to number it as well according to how we numbered it. So it's going to be 1 upon 2 times 8 times 8 again times sine of angle 150. Times sine of angle 150. So in order to calculate this, it's giving me 16 centimeter squared. Now that's done for the triangle 2. Let's find out triangle 3. Now the same method will be used for triangle 3, but there's just one problem. In this, we did find this angle out, and the length that we have is this one, and we have this one over here that we calculated in part B, which is 15.44 centimeters. And we found out this angle to be 29.47, I believe. It was 29.47. Now, in order to use the sine rule, I have this length A, this length B, and I need an angle between the two known lengths. So the angle that I would need is this one right here, the angle A. Unfortunately, I don't have it yet, but I can easily calculate that angle by, obviously this is a triangle. There's one angle that's missing in the triangle, so I'm going to subtract that from 180. I'm going to subtract the rest of the angles from 180 in order to find the angle CAB. So angle CAB will be 180 minus 29.47 minus 72. And that is 78.53 degrees. So over here we have 78.53 degrees. Now our values for the area of triangle formula are complete. We're going to use that. So 1 upon 2 times 8 times 15.44 times sine of angle 78.53. Right. So area of triangle 3 number 3, that's going to be 1 upon 2 times 8 times 15.44 times sine of angle. Let me erase this out. Let's go back. It was 78.53. Perfect. 78.53 degrees. So using the calculator, we'll find it out. 2 times. And that is 60.52. Actually, it's 526, so I'm going to make it 53. It's okay to leave the values at 2 decimal places when there are too many decimal places. Okay. So now we have the areas of the 3 shapes that make the whole design, the diagram that we just saw, the design of the logo. So in order to find the total area, the area of the logo design, we will simply add these 3 values. So 117.3 plus 16 plus 60.53. When we add them together, the answer is 193.83 centimeters square. And that's your final answer, so you will write it over here as well. And that's about it. And the question is complete, at least the trigonometry bit. So I hope you understood this question, and thank you very much.